Well, welcome back, Caymans. Mr. Eicher here, coming with part 2 of this video on lesson 2.4. If you have your notes or have a piece of paper, you can follow along. We're on number 9, which is going to lead into the next page of notes. So let's check out number 9. It says, solve for y in this equation. We have two points. We have a point x comma y here. We have a point x1 comma y1 right here. And we know that the slope is the change in y's, that would be the top, change in y's over the change in x's. And we're asked to solve for y, so let me highlight that since I like my highlighter. Solve for y. To be able to solve for y, we need to isolate y. So let's multiply both sides by this x minus x sub 1 term. So that's not going to be there anymore. So we have y minus y sub 1 equals m x minus x sub 1. And lo and behold, that's actually all I kind of want to do. We could add y sub 1 to both sides. But really what I want to do is stop here and call this is a special form. This is called PointSlope Form, and we're going to be using it on the next page. PointSlope Form is helpful in mathematics because you have the slope, so the slope would go right there. And anytime you're given one point, you would input the coordinates of that point. Right here, the x-coordinate, x sub 1, and the y-coordinate, y sub 1. So it's really helpful. Sometimes it's actually easier to use than slope-intercept form. So on the next page, point-slope form of a linear equation is y minus y sub 1 equals m times x minus x sub 1. And that's the point-slope form. So the way that this looks, write the following in point-slope form on number 10. We would have the general form is y minus y sub 1 equals m times x minus x sub 1. And again, we're going to be plugging numbers in here for the slope, here for the x-coordinate we're given, and here for the y-coordinate. And then the other x and the other y just stay put. So we would have y minus 12 equals the slope, 3/4, x minus negative 5. So this would be our answer. We could clean up the minus and negative a little bit. So we'd get y minus 12 equals 3/4 x plus 5. So this would be the answer right here. Y minus 12 equals 3/4 times quantity x plus 5. Now, it's an important skill, so the directions don't ask you to do this, but I think it'd be really helpful. If we wanted to convert this to slope-intercept form, what we would do is we'd have the y minus 12, we would distribute the 3/4, distributive property. 3 times 5 is 15 over 4. And then we would add 12 to both sides. So we get y equals 3/4 x plus 15/4 plus 12. Now 15/4 and 12 we should add, and I would like you to practice your fraction adding abilities. We would have y equals 3/4 x plus 15/4 plus, how can we rewrite 12 so that it has a denominator of 4? So what fraction is equivalent to something over 4 to get 12? Well, I think that would be 48 over 4. 48 over 4 is 12. So then our answer would be y equals 3/4 x plus 15 plus 48, 63/4. So that would be our answer in slope-intercept form. Again, the directions don't ask you to do that, but sometimes on Schoology assessments will ask you to write it in slope-intercept form, so you'll need to be able to work with fractions, kind of like what we did right here. I see number 11 is a try this. You're given 2 points, so figure out what you would do to figure out the slope of the line between those 2 points, or through those 2 points, and then write your answer in point-slope form. Number 12 says write the following in point-slope form. It's perpendicular to the graph of 2x plus 5y equals 10. And intersects that graph at its y-intercept. This form is in standard form. So how about we find the intercepts? We have the x-intercept and we have the y-intercept. So we would have the x-intercept is what is x when y is 0? So if I plug 0 into this, I would get 2x equals 10, so x is 5. So the x-intercept is 5, 0. The y-intercept is the coordinate 0, y. So if I plug 0 in for x, I would get 5y equals 10, so y is 2. So that means the y-intercept is 0, 2. So if I graph those 2 points, 5, 0 is the x-intercept, 0, 2 is the y-intercept. It looks like my slope, I could count, my slope would be down 2 over 5. So the slope of that first line is down 2, so negative 2 over 5. And I can graph at least one more point. If I go backwards, instead of down 2 over 5, up 2 and to the left 5, I'd be at this point right here. So here's my first line. So now I can actually answer the question. The question says, write an equation in point-slope form of a line that's perpendicular to the graph I have graphed there. So if we want the perpendicular slope, we can call it slope number 2, or even maybe I'll use a little perpendicular symbol. The perpendicular line would have what slope? Well, it's the opposite, so it's going to be positive, and it's the reciprocal 5 over 2. So if I were to graph this line, it's perpendicular, and it intersects at its y-intercept right here. So I would go up 5 over 2, or I would go down 5 to the left 2. And you can see that it looks like I have the right answer because they should meet at a right angle. And that looks like a right angle. So to write our equation, we would have the intersection right there is 0, 2. So we'd have y minus 2, the y-intercept, equals 5 over 2, x minus 0. That would be the point-slope form of the equation. We can clean it up a little bit and say y minus 2 equals 5 over 2x. But this would be our equation in point-slope form. Number 13 is for you, so that'll be a try this later on Schoology. And let's end with the application of some real-world data to give you some context here. This says, according to Statista.com, the following table shows the number of passengers on cruises in millions from 2009 to 2019. So we have a scatter plot here. We have the x-axis. This is years since 2009. So for instance, this 8 would be 8 years after 2009. That would be the year 2017. And then on the y-axis, we have the number of passengers in millions. So this 30, that would be equivalent to 30 million. So that's actually that 30 million right there. So if we were to pick 2 points, if we're trying to write an equation, let's go back here so you can see what the question is. It says, find the equation of the best fitting line and use it to predict the number of passengers in 2020. This and questions like it are very relevant for people who are trying to make predictions, because if you're in the cruise industry and you like to predict how many people, passengers you're going to have, that's going to affect your income and things like that. So if we were to pick 2 points, if we maybe just started and said hey, how about these 2 points? The problem with picking those 2 points is they don't really fit the data very well. Notice all these points below the line. So instead of that, perhaps if we chose, this point and this point, maybe, that would give this line through those 2 points. That doesn't look too bad. You have a couple points that are above the line. You have a couple points that are below the line. So let's use those blue points that I highlighted. Let's use this point and this point. That one on the left would correspond to 3 years after 2009, so that would be 2012. And the one on the right would be 7 years after 2009, so that would be 2016. So we're going to use those two ordered pairs to write an equation of a best fitting line. So first our slope would be the change in y over the change in x, which would be the change in passengers over the change in year. So the change in passengers, it started as 20.9 passengers and it ended as 25.2. And then the years went from 2012 and it ended at 2016. That gives negative 4.3 divided by negative 4, which is negative 1.075. So that's our slope. And then we can write our equation in point-slope form. You can pick either one of the points. I'll just pick the first one on the left. So we have y minus 20.9 equals the slope, it's not negative, it's positive. Positive 1.075 times x minus 2012. And then we'll distribute and solve, but actually we don't even need to distribute. This is our equation. This would be in point-slope form. So we could actually use that equation and evaluate how many passengers are we predicting in 2020. We'll just put 2020 in for x, the year. So we'd have y minus 20.9 equals 1.075 times 2020 minus 2012. So that would be y minus 20.9 equals 1.075 times 8. So that would be 1.075 times 8, that would be 8.6. If we add 20.9 to both sides, plus 8.6, we would get y equals 29.5 million passengers predicted. Now this prediction is based on an assumption that we picked two good points to make our prediction. It's also based on the assumption that this slope would hold to be true, but as we all know in 2020, some things happened in 2020 that probably led to much fewer passengers taking cruises in 2020. So even though our prediction might have been accurate, some things are out of our control that even mathematicians can't resolve. Thanks for watching this video. I will see you in class or see you next time.